Hi, welcome back. In this video, I'm going to talk briefly about the Pythagorean identity using sine and cosine. So in mathematics, we say that an identity is a statement that says two expressions are equivalent. So I like to remind myself that equivalent is basically like saying they're identically true. So you can think of identity and identical. So they don't look identical. We're going to have different things on each side of the equation, but it tells us that one side of the equation is always equal to the other side of the equation. And so they're identically true. So there's an identity that you've probably seen before, and it's specific to right triangles. So with right triangles, we have the Pythagorean Theorem, which is actually an identity. So we call it a theorem because it's kind of like a big deal in math, and big deals in math often get called theorems, but it's really an identity. So given a right triangle with side lengths A, B, and C, where C is the hypotenuse, we have that a squared plus b squared equals c squared, and this is the Pythagorean theorem. So this says that for any values a, b, and c on a right triangle, this statement is true. A squared plus b squared is going to give us the same value as c squared. They're equivalent. So now that we have sine and cosine in relation to a right triangle, we can rewrite this identity. So if we think about our unit circle and our sine and our cosine, our hypotenuse of our triangle would be 1. That's because a unit circle has a radius of 1. And then our side lengths would actually be cosine of theta and sine of theta. So the cosine of theta was the x, and the sine of theta was the y. So I labeled them accordingly, and then when we replace these in the Pythagorean theorem, I'm getting that cosine of theta squared plus sine of theta squared is equal to 1 squared. A squared plus b squared equals c squared. Then we just clean this up a little bit, and we put that squared inside of the trig functions, just to help us not write so many parentheses. It's just a shorthand. So we write cosine squared of theta plus sine squared of theta equals 1. And this is the trigonometric Pythagorean identity because it relates to the trigonometric functions of sine and cosine. Before we go, I just want to highlight that we can take this identity and rewrite or rearrange it to fit whatever our needs are. So it's written in the form cosine squared plus sine squared equals 1, but we can rearrange it if what we are working with looks slightly different. So for example, because addition is commutative, I can write sine squared plus cosine squared equals 1. I can just swap the order. Or I could actually subtract something over to the other side. So I could subtract cosine the squared over. So I'd have sine squared equals 1 minus cosine squared. That's also still true. We can do that. Or I could have done it the different way by subtracting the sine squared. So I could have cosine squared equals 1 minus sine squared. Or if I wanted, I could even put everything on one side. I could have 0 equals 1 minus sine squared minus cosine squared, etc. So you can manipulate this any way you want to get the version that works for you. So maybe the problem you're working with has a sine squared in it, and you'd really rather rewrite it as 1 minus cosine squared. You could use that identity in order to get that to work. So just know that all of these are equivalent statements because we have this identity, meaning that the equality is true, like both sides are equal. We can manipulate it as long as we're following the rules of what math we're allowed to do here. So we could add or subtract anything to either side. We're still getting equivalent statements, and that might help you out as you're doing some problems. And it's just good to know that you can manipulate this identity to get it to do what you need it to do. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.